When we were in primary school, we learned how to calculate the area of a right angle triangle, which is half times base times height. But that triangle must be a right angle triangle. What if the triangle is not a right angle triangle? And what if the angles are not given in the triangle? Can you still find the area of a triangle? Watch until the end of this video if you like to learn how to calculate the area of triangle if it's not a right angle triangle and there's no angles given, and also to find the missing sides and missing angles by using the sine rule and cosine rule. And we'll start right now. Hello everyone, my name is Shirley and welcome back to my channel. If this is your first time here and you'd like to improve in your math skills, start now by subscribing and clicking the bell so that you don't miss anything. Let's take a look at the first part of solution of triangles. The first thing to learn in this chapter is to understand the angles and the sides of a triangle. Okay, let's look at this triangle ABC. If this is angle A, so therefore, this side will be A. If this is angle B, so I'm going to label this side as B. If this is angle C, I'm going to label this side as C. Next, we're going to prove the sine rule. So to prove the sine rule, I'm going to take triangle BCD. So triangle BCD. So where's triangle BCD? So B, C, and D. I'm going to take this as angle B so that I can find sine B. So sine B, we know that it's opposite side over hypotenuse. So where is opposite side? So this is the opposite side and this is the hypotenuse. Okay, so I'm going to find the sine B. So sine B is H over A. Okay, then after that I'm going to make H as a subject. So it's A sine B. Okay, so next I'm going to consider triangle ACD. Okay, so ACD, and I'm going to use sine A. So angle A is here. Okay, so for this opposite side is still the same as the previous sine B. So and this is hypotenuse. Okay, so now I'm going to find what is my sine A. So sine A is equals to opposite over hypotenuse, which is H over B. So now I'm going to make H as a subject. So H is equals to B sine A. Okay, and then next I'm going to take this as equation 1 and this is equation 2. Okay, so now I'm going to put them together. Okay, which is equation 1 equals to equation 2. Okay, so will be A sine B is equals to B sine A. Okay, I'm going to take this as an example. So A over sine A and is equals to B over sine B. Okay, so this would be the formula. Okay, or you can also make sine on top. So sine A over A equals to sine B over B. So this is how you prove sine rule. How to know when you can use the sine rule? So you can apply the sine rule when one side and two angles are given, or two sides and one non-included angles are given. So what is an included angle? Okay, let me show you. So this, let's say this triangle is A, B, and C, and let's say this angle is 60 degrees. Okay, so let's say this is 2 cm is known and this 3 cm is known. So if the two sides, okay, that is between the 60 degrees are known, therefore 60 degrees is an included angle. Okay, let's try another example, which is ABC also. Okay, let's say ABC. Okay, so let's say this angle is 40 degrees. Okay, so if this is 2 cm, this side is known and this side is known. Okay, but BC is unknown, so therefore the angle 40 degree is a non-included angle. Okay, so for any triangle ABC, to find the sides, we're going to use this formula, which is A over sine A equals to B over sine B and equals to C over sine C. Okay, to find angles, we put sine on top. Okay, so sine A over A equals to sine B over B and equals to sine C over C. let's look at this example. Determine the value of m in the following triangles. So for A, the m is a side. Okay, so to find the side, I'm going to use the formula of A over sine A equals to B over sine B. Okay, so I'm going to use that formula. So I'm going to use m over sine 55. So m over sine 55 equals to 6.7 over sine 78. Okay, so that would be my working for A. So m over sine 55 and is equals to 6.7 over sine 78. Okay, now let's calculate how much is the value of sine 55. Okay, so sine 55 is, okay, I'm going to round up to 4 decimal places. So 0.8192 equals to 6.7 over, so sine 78 is 0.9781. Okay, now let's solve this. So I'm going to use 6.7 divided by 0.9781. After that, I times with 0.8192. And then I will get my answer as 5.6115. Okay, and it's in cm. Okay, now let's try for B. So for B, okay, for this, m is an angle. So I'm going to use sine A over A equals to sine B over B. Okay, so for B, I'm going to use sine m over 8 equals to sine 40 over 6.5. Okay, so sine m over 8 equals to sine 40 over 6.5. Okay, let's calculate this. So I'm going to write sine m here. So sine 40, okay, is 0.6428, then over 6.5. Okay, this one I put over 8 first. Okay, now sine m is equals to, okay, 0.6428 divided by 6.5 times 8. So we'll get a decimal, which is 0.7911. Okay, so to find m, I'm going to use shift sign, okay, of 0.7911. Okay, let's calculate this. So shift sign of 0.7911. So we'll get the answer as 52.29 degrees. And then if I want to change to degree a minute, okay, I just need to press the dot, comma, comma, that button. So we'll get 52 degrees and 17 minutes. So that's the answer. What is an ambiguous case? Ambiguous case means that there might be two possible triangles. Okay, let's look at this diagram. The diagram below shows two triangles, which is ABC and AB1C, with the lengths of two sides and a non-included angle given as follows. So for this, we have ABC and also AB1C. Okay, now let's look at the bottom. Okay, ambiguous case exists if A, given the length of two sides, A and C, and a non-included angle, angle A, which is acute. And B, the side which is opposite the non-included angle, A, is shorter than the other side, C, but is longer than the height H of the triangle. Okay, now let's look at this example on ambiguous case. So sketch triangle PQR and find the possible values of angle R prime in an ambiguous case. So given angle P is 27 and P is 7 cm and R is 11 cm. So let's sketch this triangle. So we know that angle P is 27 degrees. So it's somewhere around, I'm going to sketch it like that here. Okay, give me time to draw. So I can just predict that R is over on the right side. Okay, so let's say this is the triangle. Okay, if it's not right, we can just erase it at any time. Okay, so we have angle P here, which is 27 degrees. Okay, and then this is P, which is 7 cm. And R here is, okay, let's say this is Q and this is R. So therefore R is over here, which is 11 cm. Okay, so here possible values of angle R prime. So okay, so I'm going to draw. So if this is QR, I'm going to use a red. Okay, let's say if this is QR here, it can also be here, which is 7 cm, right? So this is ambiguous case. It can be here as well. Okay, so we just like from here, we swing to here, which is 7 cm, or you can use a compass and draw 7 cm. Okay, from here, you just swing over to here, okay? So you form a curve. So here it will be the R prime, okay? So I'm going to write there, R prime. Okay, so here will be my R prime. Okay, so this is the angle of R prime. This is angle of R, okay? And this length is same as here. Okay, so now let's solve this. Okay, so for this, I'm going to use the sine rule. So sine angle R is over 11 is equals to sine 27 degrees over 7. Okay, now let's solve this. So sine angle R is equals to, okay, let's calculate this. So sine 27 equals, then divided by 7 equals, and then times 11. So we'll get 0.7134. Okay, so do you get that? So 0.7134. So to find angle R, I'm going to use shift sign of 0.7134. Okay, so let's solve this to find angle R. So shift sign of the answer, we'll get 45.51. Okay, 45.51. So 45.51 in degree. So if you want to change to degree in minutes, we just press the dot, comma, comma, comma. So it's 45 degrees. Okay, and we have 31. Okay, 31 minutes. Okay, so this is angle R, but they want you to find angle R prime. So angle R prime is an obtuse angle. Okay, so obtuse angle, which is here, yeah? So this is 45 degree and 31. Okay, here is also 45 degree and 31. So therefore, to find angle R prime, I'm going to use 180 degrees minus 45 degree and 31 minutes. So therefore, the angle of R prime is, so 180 minus answer, so you get 134.49 or 134 degree 29 minutes. Okay, so 134 degree and 29 minutes. So that's the answer. Just now we learned how to prove the sine rule, so now we got to learn how to prove the cosine rule. So prove the cosine rule, which is a squared equals to b squared plus c squared minus 2bc cos a. So how to do this? Okay, so at first I'm going to draw this, the height of the triangle, which is h. Okay, so I label this as x and this as p, and for here it's going to be b minus x. Okay, so I labeled this first, and then after that, I'm going to consider triangle ABP. Okay, so ABP will be the triangle on the left side. Okay, so for this, I'm going to find what is my cos A. So cos, we know that is A over H, adjacent side over hypotenuse. Okay, so it's equals to x over c. And then we make x as a subject, so it's going to be c cos A. Okay? So next, I'm going to use Pythagoras theorem to solve the left side. So h squared is equals to c squared minus x squared. And I'm going to take this as equation 1. Okay, so next, I'm going to use triangle BPC. Okay, triangle BPC. Okay, so for here, I'm going to use Pythagoras theorem as well. So this will be h squared equals to a squared minus b minus x whole thing squared. So now let's expand this one, expand the bracket. So minus b squared minus 2bx plus x squared. Okay, then after that we open up the bracket. So there'll be no more brackets. So minus b squared plus 2bx, and then you minus x squared, and this is going to be your equation 2. Okay, so next I'm going to substitute, so sub equation 1 into equation 2. Okay, so we are almost there. So a squared, okay, minus b square plus 2bx, okay, then after that minus x square, okay, is equals to c square minus x square. So we just need to rearrange this, okay. I'm going to leave my a square on the left hand side and the rest I just move it to the right, okay. So we have b square plus c square, okay, and then after that we minus 2bx, okay. So from here we have our x is equals to c cos a, so I'm going to substitute this into here, this x, okay. So we get a square equals to b square plus c square minus 2b, and my x is c cos a. Ta-da! So we have proven the cosine rule. When do we need to use cosine rule? So we can apply cosine rule when two sides and one included angles are given. So let's look at this example. Okay, so we have 35 meters and 42 meters are given, and the angle is 132. So therefore the angle 132 is an included angle. Okay, or we can also use the cosine rule when given three sides. Okay, so for this example, three sides are 30 cm, 12 cm, and 25 cm. So these three sides are given. Therefore, we can apply cosine rule. Okay, so the formula for cosine rule is a square equals to b square plus c square minus 2bc cos a, or b square equals to a square plus c square minus 2ac cos b, or c square equals to a square plus b square minus 2ab cos c. Let's look at this example. So here is given one included angle and two sides. So let's say this is A, angle A, so therefore this is B and C. So I'm going to apply to the cosine rule, okay, which is A square equals to B square plus C square minus 2BC cos A. Okay, so A square is, so where is A? It says A, okay, which is x square equals to, so B square is 13 square plus C is 8, so 8 square minus 2, 13, 8 cos, so the angle is 48. Okay, so let's calculate this. So this is 169 plus 64 minus, so 2 times 13 times 8 is 208. Then times cos 48 is 139.18. So 139.18. Okay, so let's calculate this. 169 plus 64 minus 139.18. So we'll get 93.82. 93.82. So this is x squared. So to find the x, we're going to square root this. So square root 93.82. So we'll get, so square root the answer. So we get 9.686. 9.686. Okay, so that's the value for x. How to find the area of a triangle if it's not a right angle triangle? So we can use this formula. So this formula can be used if two sides and one included angle are given. Okay, so the formula is area equals to half AB sine C, or half AC sine B, or half BC sine A. Let's look at this example. Find the area of the following triangle. So for this, I'm going to use half AB sine C. So this is going to be my A, this B, and this is angle C. Okay, so to find the area, I'm going to use half AB sine C. So I'm going to substitute the values of A and B. So A is 4, B is 7, and sine C is 68 degrees. Okay, let's calculate this. So sine 68, then times with 7 times 4 divided by 2, so we get 12.98. Okay, or if it's 3 decimal places, it will be 12.981. Okay, and the unit is cm squared. So that's the answer. How to find the area of triangle if it's not a right angle triangle and there's no angles given. So we can actually use the Herons Formula. So this formula is created by a Greek mathematician called Hero of Alexandria, which is also known as Heron. So we should be thankful to him because now we can find the area of triangle if it's not a right angle triangle and there are no angles given. To find the area of triangle when three sides are given, we have to follow these two steps. So first step is to calculate the semi-perimeter, so which is S equals to A plus B plus C over 2. And then step 2 will be substitute the values of S, A, B and C into the following formula, okay, which is area equals to square root of S bracket S minus A bracket S minus B bracket S minus C. Let's look at this example. Find the area of the triangle below by using the Herons Formula. So when do we have to use Herons Formula? So we use this formula when the triangle has no angles given, but the three sides are known. Okay, so find the area. So first I need to determine the sides of A, B and C. So if this is angle A, so therefore this is A. If this is angle B, so therefore this is B. If this is angle C, so therefore this is C because it's opposite of the side is opposite of the angle. So first I need to find the semi-perimeter, which is A plus B plus C, then over 2. Okay, so A is 11, B is 7, and C is 6, and whole thing over 2. So let's calculate this. 11 plus 7 plus 6, then divided by 2, so we get 12. So therefore S is 12. Next, we're going to substitute into the Herons Formula. So area is equals to square root of S bracket S minus A bracket S minus B and bracket S minus C. So we write down the formula first. Next, we're going to substitute the values of S, A, B and C into the formula. So S is 12, then S minus A is 12 minus 11, S minus B is 12 minus 7, and S minus C is 12 minus 6. And then we square root the whole thing. Okay, so equals, let's calculate this. So this is 12, and then 12 minus 11 is 1, 12 minus 7 is 5, and 12 minus 6 is 6. And we square root the whole thing again. Okay, let's calculate this. So 12 times 30 is 360, so square root of 360. Okay, let's calculate this. Square root of 360 is 18.974. Okay, leave your answer in 3 decimal places. So equals to 18.974 and the unit is cm squared. So that's the answer. The next part is about application of sine rule, cosine rule and also area of a triangle. Let's look at this example. Mr. Lee wants to paint the roof of the garage. The diagram below is a sketch of the front view of the roof of the garage. He found out that the wood on one part of the roof is longer than the wood on the other part of the roof. So A, calculate the length of the wood on the longer part of the roof and the distance between both the walls of the garage. And B, what is the area of the front roof in the shape of a triangle in meters square which will be painted by Mr. Lee? Okay, let's solve for A. So calculate the length of the wood of the longer part of the roof and the distance between both the walls of the garage. So first I'm going to label this as y, okay, and then I can use the sine rule, which is y over sine 50 equals to 5.2 over sine 30. Okay, so I'm going to write the answer here. So y over sine 50 equals to 5.2 over sine 30. Okay, let's calculate this. So 5.2 divided by sine 30, then times with sine 50, so we'll get 7.967. So it is 7.967 meters, and this is the length of the wood on the longer part of the roof. Okay. So next one, I'm going to find the distance here. So distance between both the walls of the garage, which means that distance from here to here. So I'm going to label the triangle as ABC. So A, B, and C. Okay, and then I'm going to use the cosine rule. So therefore, I have to label the sides ABC. Okay, so here is A, side A. This is side B because it's opposite of the angle B, and this is side C because it's opposite of angle C. So I'm going to use the cosine rule for this case to find the length of the distance between both the walls. So for B, I'm going to use the cosine rule. So A will be here, A square, okay, equals to B square plus C square minus 2BC, then cos A, okay. So A square will be the BC square equals to, so B square, just now we already found this is actually B, so 7.967 whole thing square, then after that we plus with C square, which is 5.2 square, okay, then you minus 2BC cos A, so BC will be 7.967, okay, and then 5.2 will be the C, then cos, so angle A here, I'm going to use 180 minus 50 minus 30, which is 100 degree, okay, so equals, now we can calculate this. So calculate this, 7.967 square, then plus 5.2 square, and then minus 2 times 7.967, then bracket 5.2 is times 5.2, then times cos 100. Okay, so we get the answer. Then after that we square root the answer. So we'll get 10.24. Okay, so we get 10.24 here, 10.24, and it is in meter. Okay, so this will be the distance between both the walls. Okay, now let's solve for the next one. Okay, this is not B, this is still under A. So next one, let's solve for area. This is B. So what is the area of the roof in the shape of the triangle in meter square, which will be painted by Mr. Lee? So for this, we're going to use the area formula, which is half AB sine C. Okay, so I'm going to use this one, 50. Okay, so to find area, I'm going to use half. For this, I can use half AC sine B. Okay, so it will be half. So A is the length of BC here, 10.24, and then C would be 5.2, and then sine B is 50 degrees. Okay, let's calculate this. Okay, so half times 10.24 times 5.2, after that you times with sine 50. So you get 20.395, I'm going to round up, so it becomes 20.4, okay? So 20.4, and the unit is meter square. So that's the answer. Well, that's all for now. Do you wish to see more videos like this? Let me know in the comments below. If you find this video useful, hit the like button and don't forget to subscribe to my channel. Stay tuned to my next video, which is 10 years of past year questions on solution of triangles, coming up soon. Bye!